So welcome. My name is Perica Milosevic, and I work as software engineer for a company called SysDig. And one of the things I'm going to present here is an open source tool that my company works on. It's a general visibility tool, system visibility tool, but we found out it's really good when you want to know what's going on with your containers. The dark part of this talk is not going to be anything mystical. The dark part will be because we are going to look a lot at my terminal, and it has like a black background, so that's why this talk is going to be dark. Okay, so I know this talk is about container monitoring, so I assume most of you know about containers or maybe already using them. But I'm going to give like a really brief introduction to containers just to be sure we know what we're talking about. So how many of you actually use containers? That's cool. And how many of you have containers in production? That's even better. So I will go back for a few years, maybe 10 years, and think about how we used to work. So when we needed some infrastructure to run our applications, we had to order physical servers, we had to order hardware. So we had to wait for a few months before or days in best case, to get our hardware. And it used to be even worse because we had to do budget planning. So sometimes we had to know like a year before that what are our needs going to be in order to plan and to have hardware to run our applications. And then there was virtualization. So people start using virtual machines, which got things better. So we were able in a matter of hours or minutes to get our like virtual instances running, and we were able to run our applications. And as we already know, IT industry and people in general are trying to go faster and faster and lighter and lighter. And next step in this evolution were containers. So with containers, we were able to have some like piece of infrastructure running in a matter of seconds or minutes in worst case. So that was the first feature of containers. They were light and they were fast. So you can see like here on this slide, like a basic difference between hypervisor-based virtualization and containers. So you can see that the biggest difference here is that inside containers you don't have to run a copy of operating system, which makes them both lighter and faster. But what happened next? People realized, developers, that containers are a really nice way to package and deploy your applications. Especially when microservices showed up, people realized that we have now finally a good way to deploy our apps and run them in the same way on our local environment and in production. So what are the features that we like about containers? So as I said, they are simple, they're lightweight, they provide isolation for our applications, and they are self-contained, so you're able to package everything you need for your application. But exactly because of all those features, a bunch of tools that we have for monitoring and troubleshooting of our applications and infrastructure don't play that well because they are not built with containers in mind. So during this talk, we'll try to answer that question, how to see what's going on inside our infrastructure and our applications when we run them inside containers. So what are the typical things that we care about? So what do we want to know? So there are like, there are a bunch of things we want to know, but I put here these 5 categories of things which cover, I think, 99% of our needs. So we want to know what's going on with the resource usage, which amount of processor we are using, memory and disk. Also, we want to know the network activity of our applications. And also, we care about file I/O, and are there any errors generated by our applications? Not only applications, we care about the host level, we care about containers. Are some containers misbehaving and doing something bad? And also, we want to be able to track the application activity. So in this talk, I will briefly cover some general purpose system visibility tools. that we use for this command line. I will show some advanced namespace tricks for geeks that we can do to run existing tools, but inside container namespace. And I will show you the sysdig tool I mentioned that is being built by my company, which is also open source, free to use. You can do whatever you want with it. And we are going to use a demo environment. We will have like some installation with multiple WordPress instances. We're going to put Nginx reverse proxy and load balancer in front of them, and we will use MySQL as a database. So what are we going to do next? So we will create right now this environment from scratch. It's not here, so I will prove you that I'm not cheating. So let's switch to, okay, sorry. So I have set up this domain. It's fake domain, doesn't exist, where our WordPresses should show up. So they're not here. So let's switch to the best part of this. So I might have some issues with this. This is too small, so I'll make it a little bit bigger. So this is better. So I'll SSH to my virtual machine. My super secret password. Okay. Okay, cool. So as I said, we want to build an environment with WordPress. So I have issues with this microphone, but I think it will work. So I have built this configuration. Can you see the letters? Are they big enough? Okay, cool. So as you see in this config file, I have configured Nginx, WordPress, and MySQL. So it's with just basic information here. So I'm going to use this to run it. I'm going to use Docker Compose and say app and go to background. And that's it. We have our infrastructure up and running. So let me see if containers are there. Cool. It looks like working. Let us see now the sorry. I don't know how to switch this. So let me see this thing. Is it working? Come on. Okay. Let's create my WordPress. It's going to be fast. Voxed, password. Very weak, I know. Install. Did I click? No. Email address. Where? Okay, sorry. Okay, my containers are not that fast, obviously. Okay, success, cool. Let's see our nice website here. Cool. So we will switch back here. So since I know I'm gonna have like a bunch of visitors, the next thing I wanna do is to scale up this WordPress from a single instance to multiple instances. So I'll use Docker Compose, scale WordPress equals 4, and that's it. So now I have my nice demo infrastructure up and running. Let me see what's going on. Do we have everything? Yes, so our containers are here. So next, I know something is going wrong, and I want to see what my containers are doing, how they're behaving, and what options do we have when we know, like, let's start with the first thing that we care about, and that's resource usage. So what options do we have when we look at resource usage? So the common thing that users do is using top. So let's run top here to see what tops show us. So cool, top is a well-known tool. It shows us processes, shows us the amount of memory they're using, CPU and such. So let me sort this by memory. Cool, I see a bunch of Apache processes, but I have no idea to which container they belong. So what we can do here, since top is not built for such use case, so there is something we could do. There is a thing called C groups, and that's a feature in kernel that is used to build the do you see them? Yeah. Sorry, can you? Yeah, okay, cool. So now we have C groups, and now let's see this last column. It's cool. Now we can see that these processes belong to some container, and we can see even the container ID. So this is a bit better, but I'm still not able to see the resource usages per container. So what are our options here? So we tried with this like a general tool. The other tool general we could use is called htop. It has a lot better UI. I don't know if you have used it. I liked it, and I use it a lot because it's more powerful than top, but still no way to deal with containers. So we can see processes, but have no idea what's going on with containers. So we might use some Docker provided tools. It's the first thing that we could do is Docker PS. So you saw it in the beginning. Docker PS tells us which containers exist and their IDs. So this is like an input thing that we could use for other more interesting stuff. And the first thing that comes to my mind is Docker stats. So what we do with Docker stats? So you have to provide the container names that you wanna see, and then when you run it, you get this. Okay, the resolution is a bit bad, so the lines are broken. But it gives us ability to see CPU usage, memory usage, network I/O per container. So this is a bit better. The another good point about Docker stats, it has a nice REST API that you could use and to do some automation and pick these metrics through REST API offered by Docker stats. So it's nice when we detect some container misbehaving here. For example, let's say that our WordPress is not behaving well. We have another thing. It's Docker top. So let's stop this one and run Docker top for WordPress 1. So this is more like PS, not like top, and it accepts the same syntax that we can use for PS. So let's ask for more data. We have added aux, and let's see now. Okay, now I'll scroll a little bit to see just the displayed columns. Now we can see, like for a container WordPress, we can see which processes are running inside container and amount of memory, CPU usage they're using. And also we can see the PIDs of processes, which is cool and can be used for some other stuff. So I'd say that for seeing just basic resource usage information, the tools that we get with Docker are not that bad, so we can do like basic stuff, understand what are containers doing and what's happening inside containers. But what about our next item? It was the network activity. So what we can do to understand the network activity performed by our containers. So the first thing that comes to my mind is netstat. So netstat is used in general to see what's going on with network. So let's run netstat. Cool, I see 2 connections, and that's my SSH to this virtual machine. So there are no connections. And we know that there are connections here. We don't see our connections happening between containers. We know that we have Nginx doing connections towards WordPresses, and there are for sure connections between WordPress and MySQL database. So what's going on? Well, that's a nice feature of containers called isolation. So each container runs in its own network namespace. It has a private network stack, and that's cool. But the bad thing is that we cannot see what's going on inside. So we cannot see those connections. So the first thing, what would I do if I have some application, some strange network activity happening? I would try to run netstat inside containers. So I know I have identified which container is bad, but let's see what's going inside, which process is doing wrong stuff. So I'll just a second. So I'll execute bash. Let's say that Nginx is misbehaving. So I'll get bash, and now I have a shell inside container. So I'll run netstat now. Okay, no netstat. So what's going on? Well, we have hit another nice property of containers, that they are lightweight. So we don't package a bunch of stuff inside. So we have just a bare bone minimum of things inside container in order to make them lightweight. So there are one thing. Let me see if this container has apt-get. Maybe I can install netstat. Oh, sorry. Okay, cool. I have apt-get. In some cases, in some container distributions, you don't have apt-get, so you're not even able to do stuff like this. But installing software inside container is considered anti-pattern, so that's not something you want to do. So if you start installing every tool that you need inside container, you're going to end up with not that light containers, and it's not playing well with this. So what can you do now? So there is one trick we could do. So let me log out of this container. Okay, so now I'm back on a virtual machine. So there is an option to run some program on your operating system with a namespace of another process. So in this case, I will try to run netstat inside the namespace of, for example, Nginx or MySQL. So let's try with something else. I'll show you how NSEnter works. So NSEnter, it says this. So run a program with namespaces of other processes. So I'm going to do this thing here. Just a second. Okay. No. Just a second. Okay, let me find, first I need to find out the PID of MySQL. Okay, it's running. This is PID, I think I don't see now. Okay. Oh, okay, sorry, yeah. Thanks. This was too large. I didn't run that number of processes. Okay, let me see what's going on now. So you see, I'm saying like this. Okay, I want to enter the namespace. My target is that PID, and I care about network namespace. That's why I say net. So let me see what's going on. Okay, cool. Now I see MySQL connections coming from different WordPress instances. So MySQL is running on this IP address, and I see that like 4 WordPress instances are accessing MySQL. This is cool. I can see something, but this is really far from what I would like to see. So imagine the situation when you have something going on wrong, really strange with your network, some application going crazy, doing some outbound traffic or similar. It's really hard to detect what's going on, which process. There are not many options you can do in order to troubleshoot such a situation. I'll just briefly show you 3 tools intended to be used for file I/O activity. The first one is called IOTop. So IOTop displays the file I/O activity per process. Again, no containers and also no file names. You don't know which files are the process is accessing. Another thing we could use is FA trace. Okay, this thing shows the files, but not much information about the amount of reads and writes. And another thing we could do is IOStat. IOStat. So it provides some general information about the system, and it also provides the amount of reads and writes per second per device. So again, not something we could use for containers. So the typical tools that we could use on a Linux box for network and file activity are not that good. So what are our options here? Now, let's go a step back. I will show you, this is a really nice slide showing the operating system. and different layers of operating system. So in order, this slide is done by Brandon Gregg. It's a celebrity performance engineer from Netflix. And it shows different tools which you can use to understand what's going on different layers of operating system. So in order to have comprehensive understanding of what's going on, you'd have to monitor practically all these layers and interactions between layers to understand where the problem exists. Of course, it requires a lot of knowledge, and the information you can get from doing such things is overwhelming. And I'm going to show you what we at SysDig did. So look at that guy up there. It's called SysDig, and it's on this system called interface layer. What does that mean? So SysDig monitors the interactions between applications and operating systems. And in 99% of time, it's about system calls. So whenever some application needs to do something on operating system, to do something, they have to ask something from operating system, like open file, open network connection, and stuff like that. So SysDig is on that layer and monitors that. So there is a command line tool that you can download it's open source and free, called SysDig, and it captures events and allows you to do different kind of filtering and different kind of to run different kind of useful scripts on top of capturing events, and that enables you to get interesting information out of it. In the term of features, I would say it has some of the features of strace, TCP dump, LSOF, and it has Lua scripting on top of it. So you're able to write custom scripts in Lua and process the events. Besides that, it has nice user interface, similar to the one I showed in HTOP. And the most important thing for me is it has native support for containers. So I'll briefly show you the architecture of SysDig. So this is very simplistic view of an operating system, not like the one I showed previously. And it shows you some apps running, some of them inside container and some of them outside. So as I said, on this layer here, the SysDig kernel module intercepts all the activity. And what do we do with that activity? And in user space, we have application that is used to analyze that activity. What is nice, it can be run as a standalone application, but it's nice, it can be run also as a Docker container, so that it plays nice with the whole ecosystem. It has to be a privileged container, but it works okay. What is important to say, this kernel module and SysDig runs on thousands of servers in production. It's extremely lightweight, and people keep it all the time in production, because the serious effort was put into making it performant, and since it intercepts everything that happens on operating system, it can really slow down everything. So that's something that we really took care about, to make it performant and not to slow down the machine. So I would say that the performance penalty of running SysDig is really trivial. So let's see what we can do with SysDig. I'll show you. So I'll start with very simple stuff, and then I'll make it better and better. So it's interesting to see what can be achieved with just by monitoring operating system calls. So let's run SysDig. Now we will see everything, which is not good, because we see practically every operating system event happening on my machine. So what we should do with this, because I'm not sure, like, is there anything useful we can get out of it? So the first thing I said, we can do a bunch of filtering out using SysDig. So we can filter out some events. So it can be a little bit better. So let me see, what can we use to filter things? So it really depends on a type of operating system event. It can be something, so if it's some event related to files, then we have some file metadata we can use to filter events, like file name, I don't know, process accessing it, stuff. So there are a bunch of things you could use to filter events. So okay, it's nice, we can filter stuff, but it's still not something that, like, it's very useful. So I'll just show you how we can use, for example, let's see just the events related to MySQL. So I say, okay, run sysdig, and I want filter by process name, call it MySQL daemon. This index might look familiar to people who used Wireshark before, and that's not by accident. The guy who wrote initially sysdig is the guy who was one of the authors of Wireshark. So there are a bunch of ideas from Wireshark that are built into sysdig, like the way to filter stuff. So now, okay, now we are seeing some events, still not very useful, but it's a bit better. Now we can see like just stuff related to MySQL. We can see the container ID, which is cool, container name. So right from the beginning, we can already see some container stuff happening here. Now, I'm not gonna go like in additional filtering. I'm gonna show you now how we can use sysdig to achieve the things we said in the beginning, to see resource usage, network activity, and stuff. So let's start with the resource usage. So I won't use the plain sysdig. I'll use the thing that has user interface. It's terminal user interface, but it's still better than seeing these letters flying in front of you. So let's see what's going on here. So the first thing we can do is to click. So it's better than nothing. So let's see by like memory. Okay, now I can already see my containers here. So what I see here are processes. For each process, I can see the container name. If we go to the right, there are like other stuff useful that you can get, and these views are configurable. So there are a bunch of views here that we have already built in. So switch here and just select view you care about. So let's see just the containers, for example. This is cool. So I can see just my, like how many, 6 containers. For each one of them, I can see CPU usage and some other additional information, like the amount of file activity or processes threads. And you can also add another fields here. You can also do filtering, which is cool. Like I can say something like this F4, and I just care about MySQL, and here it is. I just get MySQL. So I think this is good enough for seeing the resource usage. So let's see now what we can do with network activity. So I'll just select another view here, and I say, okay, let's see the connections. Okay, this is a bit better. Now I can immediately see all the connections happening on my system. So not only external connections and host level connections, we can already see what's going on inside containers and the activity between different containers. I can see the protocol used for some connections. You see, we detect some of them like SSH, HTTP, so we don't have to guess by port what's going on. Also, you can see the container IDs, the amount of traffic happening, and some other additional information, which I find pretty nice for one thing that you can run in terminal. So let's see if we can do some like live troubleshooting. Imagine that we have like some container doing some crazy stuff. So let's order this by bytes in. So I'm not satisfied with this. Where's my Nginx? I don't see it. Bytes out, SSH. So let me see, let's start with containers. So I can filter by container now. Where is it? Okay, I'm now seeing processes only of that container. But let me see if I can see connections only. Yeah, I have some fake client running, just using curl to ping it. So there is some activity happening here. So let's see what's going on here. So there is some nice thing we call an eco mode. So let's run it. It's in F5. Okay. So what's going on now? Nothing. Let me go back. I've chosen the okay root. Where is my mouse? No, network. Here. Okay, cool. So let's see some. Let's make it better. Okay, we cannot see here. We can see live requests coming through this connection. So I have switched to like a more user-friendly, like ASCII mode to see what's going on. So let me pause it. So this font is blue, which doesn't make it very readable. But let me see if I can see here, just to find one nice request where you can see what's going on. And we can do like additional filtering. So what we see here, we can see that there is a GET request coming from curl from my virtual machine asking something, this Nginx. You can see it's read. And then we have immediately followed by write, which forwards. You can see, if you can see this X forwarded by 4, you can see how Nginx is forwarding these to WordPress instances. So you can see a bunch of stuff using this method, which is also cool. So you don't have, like, sometimes when you just want to see briefly what's going on with some connection. You see this connection is going crazy. Okay, let's just see what kind of data is being sent to this connection. So what did I do here? Okay. Let's see the file activity. Am I too slow or too fast? Maybe. Okay, I have this filter by container. Let me restart it. It's going to be better. Okay, I want to see. No. Okay. Oh, sorry. Let's see files. No, file open list, files. So what do we see here? We see containers. We see which files are being accessed. We see the amount of traffic between container and files, which is pretty nice. We were not able to get anything similar by using the standard tools that we had. You can also do some crazy stuff like this. So okay, this is UU random, but let's see here. etc hosts. Let me see what's going on here. What is being read? Let me switch to printable stuff. Okay, I can see the content of my host file inside container, which is captured live from something not even running close to that container. It's running outside in another container, and we can see pretty much everything going on inside, which is a bit scary. So another thing, I'll just go quickly through some other things. Let's see errors. So I told you I have some client using curl just every second doing some queries, but also I run one client misbehaving and asking for some URL that does not exist. Okay, here I can see the containers and some errors being generated. So I can see that, I don't know, WordPress has 3 file errors. So let's see what's going on here. InnoEnd. So if you have done some low-level programming, InnoEnd means no such file or directory. So this might be okay. But we can do another thing. We can dig. So digging shows us the events. So let us see what's going on here. So to see which resource is actually being accessed. So there is some, okay, I'm not WordPress expert, so I have no idea what these things are doing, but you can see like if there is some file missing or stuff like that, the application tries to access it. And I'll now just do one quick troubleshooting scenario where we have something wrong going on and we want to detect what's actually happening. The good workflow that people usually do in such a situation is when you have some problem in system, you run something to capture what's going on, and then you do the analysis later. So you don't want to run expensive analysis on your system that already has some issues. So I'll run now a sysdig, like a plain sysdig, and it's going to capture what's going on. So and all the system events being captured are going to be stored into this trace file. So okay, I'll let it running for like a few seconds just to allow my bad misbehaving client to do something wrong. Like for 10 seconds should be enough. Okay. So I have this trace file. Let's analyze it, but we will use sysdig. Sorry. And you can see that I don't have run sudo now because I'm just doing the analysis, so I'm not capturing anything. And as I said, the whole analysis happens in user space. So this is the same thing that you get with real-time experience, where you can see things happening on your system. But now we are looking at the trace file captured by, in this time it's on this system, but in reality you can capture something on a server in production, bring that file and then analyze it on your local machine. So what we can do here, let's try to find, okay, I'll exit this. So I assume I have issue with some 404 errors. Let me see if I can find them. I'll just filter events from this event buffer from this trace file to see if there are 404 errors. Okay, I didn't capture them. It didn't run long enough. But what could I do? I could find the event, then I could find the PID, and then I could see the whole exchange that happened and capture which exact URL was asked and returned with 404. So this was just like a small example what things we could do on a host just with the command line tools. Of course, there is always a question what we can do if I have cluster. If I told you we have like thousands of servers running sysdig. We have another, it's our commercial offering that is software as a service, but also it's on-premise solution, which allows you to run it and see what's going on with your infrastructure and processes. I'll just show you quickly here how it looks like. Okay, just to find my mouse. Okay, this is a bit... Just a second. Okay, so I'm looking at some demo infrastructure running on Amazon in US East region, so I can do custom grouping here, and I group by instance tag. So since this is Amazon, the system captures those tags, so I can see the names of instances, and inside I can see the hosts. Okay, this web app is a single host, and inside I can see containers. And like typical monitoring solution, I won't go in details now. You have all the stuff like monitor, alerting, dashboarding, and such. I want to show you this one nice thing here. So I have some dashboard prepared on time. So look at this thing here. It's out of those bunch of events captured on your operating system. We can generate a topology map of my whole infrastructure. In this case, it's not that simple infrastructure. And I can see this is grouping I use there. So those are like tags. There is web app tag, Java app tag, stuff like that. And inside there are some hosts and containers running something. So all this comes from that little thingy that we showed in the beginning, and which is even better. I can do stuff like this. Let me see. Oh, okay, cool. I have here 2 machines under this group. Okay, this one have 1 container. Okay, this one runs 4 containers. And I can go deeper. I can even see processes. Okay, let's see this one, what's going inside. Okay, we have Apache here. So it's like Google Maps of your infrastructure. And all that information comes from that bunch of letters that we were capturing on your operating system. So let's end this. No, you define, you say, I want my infrastructure grouped by that tag. And this thing is generated out of that. So, okay. This is Q&A if you didn't understand. Yeah. So the question was whether SysD Cloud works on premises, and the answer is yes. Yes, we support. I didn't want to make presentation of SysD Cloud. I just want to show you what our open source tool is able to do. But yes, on commercial offering, we have full support for all orchestration frameworks there. It's native. You can like automatically get things grouped by Kubernetes, pods, namespaces, Docker Swarm stuff. So we tend to support all of them out of the box, and bunch of other stuff. But as I said, this is not like part of this presentation here. Yeah. Yeah. So for us, it's, so the question was which cloud providers. Yeah, but you could see that that SysD agent runs really low level. It's on operating system, so we don't care about cloud providers. It just matters what amount of metadata we are able to capture from different cloud providers. So with that, we add that support like provider by provider. Sorry, one more. A bunch of them. So I work on a different part of the system, so I don't want to tell something that's not wrong. But on our website, there is like a comprehensive list of all the supported distributions. We don't support Windows at the moment. We would like to support it, but you know, it's still not there. Yeah?
Does the SysD have some kind of web service that you can query like Docker?
Yes. If you're asking about SysD command line tool or the cloud.
Yes,
Command line, no, it's not like a service. It's a tool that generates output data, and in a Linux way, you would create something that consumes the data. So there are few options there, but what people initially do is do some custom Lua scripts that process that and can do a bunch of other stuff with it. Lua is really nice, and it plays very well with C++, and it gives good performance.
What about the cloud solution? You said it's commercial, so is there any variant that is it commercial and hosted and uses software as a service, or is there some community variant that I can install if I have?
I have no idea. I have no idea about it. It's a question for sales, I assume.
So on-premise variant is also commercially sold, right?
Yes.
It's the only way.
So for sure they're both commercial. I have no idea if there is a way to try it, what kind of trials we have and stuff. So, yeah.
Is there a way to send the metrics to like over the network, like Collective does, for example, to some kind of database so that I can like Grafana afterwards or something?
It is possible, so that's exactly what we do. So our agent is just a thin layer on top of sysdig, and it captures, does some aggregations and send to our backend. So the same way as we did it for our commercial offering, you can also do it with just using the open source part, and then just to like pipe all those metrics that you care about into some other type of system. No, agent, yes, agent is commercial, but the part where agent is different from command line sysdig is not that big. So it's something that gets that data and does some aggregation and sends to our backend. But the core technology, which I find like the most cool in this whole product, is the core technology that is able to capture all that stuff. It's free. Any other questions? Okay, thanks for coming. Yeah, sorry.
Yes, sorry.
Yeah.
So what's your role in this? Because you explained the tool, how it works.
Yeah.
What do you do?
I'm backend engineer, so I'm the one that accepts all the data coming from agents. So it's a bunch of data. For example, like, I don't know, so I don't want to say numbers, but like between 10 and 20 gigabytes per hour of data coming from our agents to our backend. Yeah. Thank you. Yeah.